All right. So let's say we have a number like 301, and we're trying to subtract 285, right? Now, one way to do it is by borrowing. Now, the problem with this method is it's easy for you as an adult, but to a child, it's a bit complicated. For example, if you're borrowing 1 from 2, when you add that 1 to 0, why does it become 10? Why doesn't it become 1? Because 1 plus 0 is 1, not 10. Okay, you might say, well, you're not borrowing 1, you're borrowing 10. And that's the truth, you're borrowing 10. But why are you borrowing 10? This is the 100 rule. So if you borrow 1 from 3 and it becomes 2, this 300 is becoming 200. So it's not 100 you're borrowing, is it 10 you're borrowing? It can be a bit complex to explain, and many children struggle with the concept of borrowing. So instead of borrowing, why don't we apply the same difference? For example, 301 minus 2 is 299, right? Minus 2. Now, 285 minus 2 is 283. Now, the goal is to arrive at a number at 9, or a number that ends in 9 or 99 or 999. You see? And you know why? The reason is because 9 is the highest number, highest digit. And as the highest digit, it can subtract anything. It can subtract as high as 9 without needing to borrow at all. But 8 can only go so high. It can't subtract from 9. It can't subtract 9, right? It can't subtract 9 from 8 without having to borrow. But 9 is the highest digit. You can subtract anything from 9 without having to borrow. So you're trying to get a number that ends in 9. Now, 9 minus 3 is 6. 9 minus 8 is 1. 2 minus 2 is 0. So we're basically getting the same thing. But now here it's much more straightforward. No need for borrowing, no need for extensive explanations. Once again, the reason this works is because 9 is the highest digit and you can subtract anything from 9 without needing to borrow. So any number you're subtracting from another, just turn the number up to a number that ends in 9. This is only necessary if the number up has digits that will require you to borrow, because the digits below are higher than some of the digits above and it will require you to borrow. Instead of borrowing, just turn the number up into a number that ends in 9. In this case, you subtract 2 and you subtract 2. So, a quick one. Why does this work? Let's imagine you are 9 years old and your sibling is 4 years old. In 2 years, you're going to be 11 and your sibling is going to be 6. Same age difference of 5, right? 4 plus 5 is 9, 6 plus 5 is 11. In another 2 years, you'd be 13 and your sibling would be 8. Once again, same age difference. Now, the age difference remains the same because your number of years and your sibling's number of years are changing by the same number. The same thing here. As long as you change this number up, 301, by the same number as 285, whether it means you add 2 or you subtract 2, you're going to get the same answer because it's still the same difference. So another way I can illustrate this is by using this number line here. You see, this is 301, this is 285. The difference between this and this is the same difference between this and this. They're all the same differences, right? So subtracting this from this is the same as subtracting this from this. So why don't you subtract this from this instead? It's going to be so much easier because 9 can subtract any number at all. Alright, so this is just a quick way to make it easier for your kids to understand.